All right. So good day to everyone. Welcome to these emerging areas knowledge sharing series. This is a monthly series organized by the emerging areas team out of the energy sector group of the Asian Development Bank. My name is Mike, and I'd like to acknowledge those who have helped organize this webinar. Lilith, who is based out of the UK, very early there. Thank you so much, as well as Gina, who's been supporting us out of Manila. I'd like to welcome everyone here. I think we have a few participants coming from the Pacific, Southeast Asia, and all around the world. I'd like to give the floor to the director of the Emerging Areas team of the Asian Development Bank, Dr. Cindy Tiangco. Cindy, please.
Thank you, Mike, and good afternoon from Sydney. So good day, everyone. I am pleased to open this webinar, the fifth in our series of knowledge events organized by the Emerging Areas Team Energy Sector Office. I'd like to extend my welcome to everyone who has joined us this morning or this afternoon, especially our friends from the power utilities and finance sectors, as well as my fellow ADB colleagues who have joined us today. Artificial intelligence, or AI, is definitely one of the most talked about topics nowadays. Its application spans almost all aspects in today's modern living. For those of us in the energy sector and for energy consumers, whether as individuals, businesses, or communities, AI offers a range of benefits that can significantly enhance efficiency and effectiveness. Today's session promises to be an insightful one, as we've invited two distinguished speakers to share their knowledge on AI, digital technologies, data science, and their role in driving innovation within the energy and power industries. We are excited to explore real-world case studies that demonstrate how these technologies are being applied in power generation and distribution, and helping to improve reliability, operational efficiency, and customer service, all while promoting sustainability and reducing carbon footprints. For consumers and businesses alike, we also gain a deeper understanding of how AI and digital tools can help us manage energy consumption more cost-effectively and sustainably, enabling us to make informed decisions when selecting energy providers that align with our environmental and financial goals. I'm confident that today's discussion will be both engaging and enlightening, and I look forward to learning alongside all of you. Thank you and welcome to this webinar.
Thank you very much, Cindy, for that wonderful welcome and opening message. I think we have with us two experts in the data science and AI field, and applied to not only digital transformation, but also use cases in the power and energy sector. So welcome to our two speakers today, Luis and Darren. Just checking. Yep. Okay. Thank you so much. That's very good that we have you there. First up, I think I'd like to introduce. I will call him Professor Luis Gonzalez because he also has some teaching appointments. Has 25 years of experience leading and developing AI solutions, enterprise software, and digital transformation in the power industry. He has been involved with over 50 customers in Asia Pacific, North and South America, Europe, and the Middle East, and currently focused on expanding the development and implementation of data science and artificial intelligence solutions for Aboitiz data innovation, while in parallel supporting the enhancement of operational efficiency, revenue generation, risk management, environment, social, and governance, ESG, in Aboitiz Power Corporation. So let's welcome Dr. Luis Gonzalez. Round of applause to you.
Thank you very much for the kind words. I'm happy. Can I be allowed to share, please? Thank you.
Yes.
All right. So today my presentation talks about the real use cases in the power industry. I'm hoping that for all of you, this would be an eye-opening aspect of what are we doing that makes sense in the power industry. I try to bring you examples that I know are working already, whether we're working on it ourselves or whether I've seen it work in other companies. And if you have any questions, feel free to put them in the text. I'll be happy to take some of those. My role is to lead the development of AI solutions in power. I do have two hats within the Aboitiz group. I work as the Chief Data Officer for Aboitiz Power, as well as the Operating Officer for ADI. And I also help lead their applied research. ADI, as you may or may not know, it's a company, a data science company of the entire Aboitiz group. And I sit in that crossroads between the data science and the power business. Now, I'll give you some examples of what we've been doing, but give you some context as to what has been driving some of these use cases in real world, especially the ones that are viable. Most of the disruption that we are seeing is not just driven by legislation and the intent to try to decarbonize. I think a lot of that is also key to allow our systems to become more resilient, not just from climate change perspective, but from the ability to optimize different use of fuels, as well as to try to incorporate as much as we can emerging technologies that perhaps bring the cost down of generation as well as sustain distribution. So there's been a lot of attempts in making the reality of hybridized systems, I would call them, and not all of them have gone really well. What we have realized at the end is that to introduce resilience into our grid, into our offerings in power, you gotta have AI. AI helps broker make faster speed of decisions, and it definitely helps in the ability to semi-centralize, I would say, our actual entire systems from generation, distribution, and customer service or retail. As well as help us optimize the way that we trade power for those customers or for those countries that can trade. Now, the reality is that we're all trying to move towards a decentralized world where the energy is generated closer to its use, where there's less losses in big transmission or less losses even in unused power. But to move to that objective, we really need to stabilize our investments. And as we all know, stabilizing renewables is actually quite hard. So the intermittency problem is really significant. So what we are in reality is in this semi-centralized world where we are starting to do investments that help us move away from traditional central generation. And those investments need to really return back the right amount of value to be able to stay sustainable. And we're fighting, we're using AI, we're using other tools, anything available to us to be able to manage the disruption and do the right efficiency and cost trade-offs, which is really interesting because at the end of the day, not all of our investments work well, but when they do realize, or they do deliver resilience, what I would call the ability to handle asymmetric demand, the ability to handle multiple fuels, the ability to handle changes in weather. So if I was to give you use cases, you already know some of the power generation use cases, which basically go after health monitoring of the plant, so predictive analytics, being able to understand better when things are about to break. This is all working in production, being able to centralize the data of multiple sources of generation in one place. So the idea of centralized operations are a reality now, and advanced analytics to help us understand where not just the health of plant is going, like we have in these use cases, but also where the emissions are. Now, this is not necessarily new. I mean, generation plants have been using some of this technology for a while, but how does that extend to distribution and customers? And this is where I show you this bit. In reality, it's not just necessary to have one source of generation be, I would say, approachable, but also predictable. It is very important to understand the trade-offs and the impact that it has on the rest of the value chain, right? So when you think about what we do in generations, we try to increase output, we try to raise efficiency, increase availability, improve reliability, and reduce maintenance costs. That's most of the business cases that AI has already done in generation. But how do you transfer that into actual gains across the grid and across to customers. So we see things like actual heat rate monitoring, a lot of the ability to maintain thermodynamic efficiency for megawatts efficiency. So moving from heat to electric efficiency, the ability to also automate the grid, that continues to happen, and more so we see smart switching solutions, load balancing solutions coming on, and different levels of ability to do it. But the more that these systems are connected and have data, the easier it is to anticipate what they will do and to recommend better ways of doing it. The other thing we see a lot on the grid is compatible units and geostructural monitoring. What that is being able to determine the health of those assets using drones or using satellite imagery in a way that permits to do broader amounts of territory, especially in countries where we have a big vast territory, not necessarily enough people to go around and inspect them. And then you see that also affecting the way that we do energy economics. So a lot of the way that we trade power can be optimized in a portfolio based on understanding where fuel comes and how it's used in the power generation and grid, as well as how we see bill shock forecasting to be able to maintain, I guess, the consumer's efficiency of maintaining costs down and affordability up, right? And this is actually particularly important in Southeast Asia because this is where we find a lot of the losses happen, not just on the way that power is used, but on the way that collection of power costs are obtained. And we see that a lot in the grid side, to be able to recover revenue quickly, to be able to reduce the cost of things like disconnections, as well as collection of unbilled revenue. So you see there's a lot of use cases that help make the grid smarter, make the generation more efficient and more available, more flexible, and make the customer more aware, and perhaps even protect the customer more. What we're looking at the end of the day is to drive different behaviors across each of these three to make this more efficient and make the entire system more resilient. Now, if we think of net zero, right, what we're really doing is, by being able to create this monitoring, this ability to understand the impact quickly with signal identification, we will be able to do better interventions. Interventions not just on asset reliability, but also intervention on perhaps user behavior, intervention on fuel acquisition, intervention of prevention, perhaps just the fact that we run a simulation and in storm season, we're going to have to do things differently. And once this intervention is able to be matured, which at this stage we're just beginning the level of intervention, then we can actually scale. And that's how the net zero roadmap will happen. So it's early stages. You see AI already helping on the monitoring and helping on some efficiencies. What we don't have yet is a full capability to monitor the end-to-end of the entire system to be able to scale it. So you'll start seeing more things happening with regards to, this is an example of a project with regards to monitoring and anticipating the impacts of climate change, and hopefully with this come up with new scenario building across the entire grid. So this would mean what would happen to our water, for instance, risks based on hydroelectric supply, and what does that mean on the ability of having flooding or drought, and our ability to contribute with hydroelectric resources. Same thing can happen for weather, and what does that wind prediction allow us to determine with regards to wind generation, or with sun exposure. And as you're monitoring sun exposure and perhaps drought for forest risks, you would also be able to do better scenario building for solar generation. In that, the world of monitoring for weather and patterns will start merging more and more with the ability to simulate what our power systems would have. And in that, I think it creates a lot of potential for us to be able to run our not just more accurate approach to the way we use our assets, but also to be able to anticipate investments for more effectiveness, which today, that's one of the biggest problems, is that we end up investing huge capital dollars, and not always do we have the desired effect when it comes to sustaining power reliability and availability for different citizens. So that's an example of things that I see that are already working. I leave you with this page of outcomes that are already able to happen based on AI solutions. There's, I'm aware of about a good 70 different use cases in the power sector, from generation all the way to commercial and trading. I think at this stage, we know that AI is real. It has impacted significantly different areas. The most difficult aspect of it is to match legislation and process the way that we run these companies to be able to use some of these use cases, as well as the investment that is required to get data. Okay, so I'll leave you with this. If there's any questions, I'm happy to take them from here. Thank you for their time.
Thank you so much, Luis, for those real-world use cases or data science and AI. Thank you so much for sharing as well some form of pathway in terms of sustainability strategy that incorporates data science and AI in the power and energy sector, be you utility or generation or other sort of asset management. In the Q&A later, we'll run through some of the questions that we may have received. For now, I'd like us to look at our next speaker. You may want to sort of share your screen there. Just making sure that you can do that as well. Our next speaker will present on energy and data, bridging the gap. Darren Young, who has 30 years of experience in IT and telecom, with 10 years in management consulting and 20 years in industry. He has led strategy work to help define new operating models, as well as large-scale technology, data, and system deployments. Darren takes a client-centric approach and looks to focus on specific problems and challenges in the client's environment, and looks to address and solve these with specific cases or broader systematic change programs. Darren is currently a partner with Baringa Partners LLP, focusing on their strategy, digital, and technology consulting projects. Let's all welcome Darren.
Hi,
Darren,
can you hear me, Mike?
Yep, we could hear you okay. Floor is yours.
Great, thanks. And I hope you can see my screen. Well, first of all, I want to thank ADB for inviting me to present and share today. And as Mike mentioned, really interesting space, and also what Lewis shared as well, around data and AI. I'm quite passionate around sort of connecting technology stories and how do we enable markets. And as I understand on this call, there's probably quite a broad range of countries and nations that are being represented, ranging from sort of emerging markets, but also perhaps those that are looking at more developing and developed nations as well. So what I wanted to do today was to sort of share with you two layers of perhaps what we are seeing in the market, and a bit about Baringa. Baringa are energy specialists based in the UK, and we really look at driving and supporting the energy transition story for countries, and now we're looking more specifically around how do we leverage data and AI in that space. So as mentioned, and sort of dovetailing a little bit into what Lewis is mentioning today, is that what we're seeing today is that, you know, we are seeing efficiency being the primary focus that is driven by insights of information. And so, you know, by articulating what we think is a problem statement here, and this is really one that each of you can sort of think about, is, you know, around efficiencies, how could your, you know, energy or your power efficiency be run more effectively around the scope of power generation, distribution, and retail. And when you look at the context of AI and data, these can often reduce costs or improve the way you engage with your customers. AI, you know, without data makes really no sense. So really, I think the first thing to look at is, in your organizations today or in your operations today, is what data do I see? And if I were to extrapolate that data out across months, years, layer in, you know, and again, Lewis mentioned, you know, instances of weather or other areas, what shifts in your world that enables you to then better anticipate or predict the future, just as what GPT does, or what AI does in terms of algorithms. When we, use a Netflix or you use some kind of shopping cart, they recommend things. That's all driven by data. And so if you take that thinking and apply it to your world, how could you be more effective in the way you price, interact, distribute, and plan for your power across your country, your nation, etc. Having said that, there's also these future models that we're also seeing, and we're seeing that technology is starting to interact new ways of working. And so because energy is a very capital intensive business, it's very hard to swap out infrastructure or swap out what you've invested in. The traditional thinking is, I want to sweat my assets, I want to monetize those. If I bought a generator and it's 5 years into a 30-year life cycle, I'm not going to swap that out. But those generators may not be the cleanest. So the questions we're looking at is, how do we build sustainable models? How do we build sustainable practices? And I'll share a bit about some of the ways that we're looking at working with multilateral banks such as ADB to help support transition conversations. And in that, perhaps also give you some ideas around how that could, you could look at leapfrogging energy transition in your countries. So this slide really captures what we're calling bridging the gap. And bridging the gap is really the role of data in this digital physical world where you've got traditional operational technology and digital technology converging. And today I will touch a little bit on digital twins and real-time data. But if you go around the wheel, there are multiple facets that energy is becoming more and more important, and data enables us to basically have a better hold of these areas. So security is one. So we know that security of energy and energy in itself is being such an important aspect, and with technology accelerating, it's becoming more and more important for us to figure out how do we have a better stranglehold over the security of our energy, other areas such as food and water. So these are all important things that as a nation, we start to look at. Sustainability, I touched on that earlier, but being sustainable in our practices, playing our role in our climate targets is really important. And in many countries, particularly emerging markets where they don't have access to sustainable energy sources, what can you be doing in those circumstances? Is it solar? Are there other ways of generating storage of power, such as batteries? Like, how do you pivot without having to redesign your infrastructure when you have limited time, funds, and access to capital? Consumer and energy. So there's obviously a very distributed way in the way that we are now interacting with that, and the smart home is a classic example. We're seeing in markets around the world where people with solar panels are now earning money because they're giving money back into the grid. So they generate more power than they consume. But in the context of that also is that the electricity providers are now having to relook at their revenue models, because where they had X million paying customers for energy, now they've got people who are pulling grid energy into the grid. And without good management of how they distribute that energy into the grid, they could be wasting energy and not planning well enough. So their whole business model is shifting around the way energy flows. And then AI and robotics. So I'll talk about AI across all areas here, but AI in itself is a specific area, and how robotics is really trying to transform the way energy as a whole is being looked at. So as mentioned, I'm going to touch on real-time data, and that enables AI across large data sets. So if you look down the left-hand side, we're looking at what we're calling as potentially data inputs. So network, system, process, assets, and components. And that will change and will be different for each of your environments. But as you go from left to right, those data inputs can impact areas such as predictive maintenance, fuel optimization, enabling you to do remote monitoring via digital twins, load balancing, all of those areas, and those areas can change in the middle. And on the right, it impacts your production, your costs, and even carbon monitoring and capture information. So as we start to look at inputs of data, areas of focus, and outputs of that, it starts to make you think about, well, what if I had complete and infinite information using AI to ingest? So just like a ChatGPT trawls the web and finds you all the information you need, what if an algorithm was able to do the same for any of these areas? And rather than have a person filling in a form or monitoring a meter, like, is the information that I gather could be more scalable and more effective in running my sites, my assets, and my devices down the bottom. So what this does is drives across the top multiple benefits for an organization. So I touched on efficiency. So how could I better utilize the information to basically load balance my energy network or distribute energy in a different way? How can I better use this for safety and risk? So we're even using, fall detection for cameras and AI information that basically helps with safety. Predictive maintenance and asset, I'll talk a bit about that in a second, but obviously we're seeing huge opportunities there with respect to reducing costs, because we know that often assets in markets are not necessarily the best maintained. Fuel is something we look at, but also how it's being maintained and managed can improve reliability, reduce downtime. So I was talking to someone that was saying when their turbines are down for a day or two, you're losing $1 million a day. So being able to better anticipate those, and just like maybe another level, like if any of you watch the F1 where they can see through telemetry information and they can anticipate things. The one thing I learned working with a number of companies with sensors is that, like an engine performance degrades, and at the point of it being not usable or breaking down, there's a downward performance time frame of which it's performing worse and worse and worse. So from a person's driving a car point of view, you may not realize your engine is getting worse until it actually dies, but there are particular metrics. And so what are those metrics that you can monitor so that it enables you to interact at the right time before the asset fails? Design and optimization. So once you know energy profiles, who's demanding and when, the as you're building out new cities or expanding into new areas to support the grid, like, this information helps you in planning. And then real-time collaboration. So there are, we talked about digital twin, but I'll show you some of those examples where you can do remote real-time monitoring of sites. So practically speaking, these are some examples that we're looking at. So how data can improve existing operations. So I talked about efficiency earlier on. And, if you look at the blue pillars, if you can just imagine that your current manning costs are on the left and your future manning costs are on the right. And if you look at targeting areas that you could basically improve efficiency, how does it take manpower out? How can I do it multiple times than a person could do using data information? So how do I improve my processes? So these include things like, alarm management, monitoring, all those areas that you can look at in improving efficiency. Field operations, so you can automate data collection rather than having people to go out into the field. So these include sensors, IoT sensors, and the like. Maintenance and inspection, I think that's quite a big one, because as mentioned, when you're running assets, the efficiencies that you can employ using data can improve significantly the cost for the business. And then supporting services, so other areas like supply chain logistics. So when you add all those things up, your net impact is quite significant. Now, you could redeploy those resources and costs into other parts of your business, or perhaps even upskill them to focus more on using data and information to improve your business. And so when you start to look at it more broadly, you're looking at AI and data that can enhance planning across things like consumer and household. So tell me more about who's using what and when. and what are the peaks and lows of my energy consumption. Grid planning, as mentioned, where is there more demand and why? And where is there grid choke points and where do I need to manage that? Power demand and supply, how do I price more effectively? So we're seeing in markets where there's opportunities to have more daily load shapes on an hourly basis. So information that would help you basically price better, or with that information you can provide tariff settings or methodology to basically tier. So just like with mobile phones, you got different plans. You could have more granular plans in your power models with information, and your data and systems can bill and price those more effectively. So the net impact is, better management of your total supply of energy with your demand, but better outcomes of revenue in your modeling. And then failure rates, being able to track and manage reduce failure rates over time. So with that, I'll pivot on to this area on digital twin. I'm not sure whether you'll be able to see the video, but hopefully it'll work. So the two areas I want to touch on are, we've been working with companies who basically, it's quite amazing technology where they take 2D satellite images, multiple sources of those, and then using AI, they render a real world image of what you will see. So imagine Google Earth taking drones. This imagery is as good as better and can be done within 15 minutes of the request at per square kilometer. We're also looking at city, they've done city level. So governments like Saudi government, Singapore government, Hong Kong police have used them. And not only have they done the first item, they've now integrated cameras with AI and sensors and switches, so you can actually go into that world of that environment, indoor environments, and turn switches on and off and manage and monitor. So I'll show you some videos in a second now where you can see what that looks like. And the idea is that the technology is there now to be implemented. And this goes into many other areas such as scanning crops, fields, anywhere around the world. So I'll play this and as you're seeing this, I'll talk through it. So Keppel is a infrastructure provider in Singapore. They've used this technology to create a real-time dashboard of basically of Singapore and their buildings. So all the images that you see, including this, is all generated through AI and satellite imagery. And they've converted that as you go deep down into the building levels. So if you just focus on the images, those are actual images that they've used through the satellite and convert them to real world. And then what they do is they plan. So each of these buildings are now modeled and actually digital twinned in terms of like a more of a graphical digital twin in the way they interact. So if you imagine data coming out of that, this is all in a command control center. They're able to also break it down. So architects are using this for building. Now, what you're seeing now is a real-time camera in there. You can see how they're seamlessly moving and navigating, and you'll see that on the next page. But how that actually works is that you can do remote site visits. So all of these cameras are stitched together. The digital twins are brought into the real world, and the information is brought into that real world too. So the implications of this is not just in terms of power, but also consumer retail. You can virtually go to a flagship store of an LVMH store and buy a bag and interact with that. So they have built this into their model where you can actually interact and digital twin it. I talked a little bit about these cameras. So this shot here is not someone walking through videoing it. It is someone on a mobile device wayfinding their way through this building as though it's a person. That's only done through cameras. So you can see the movement is seamless. It's as though someone's walking through, but it's not. And you'll see why in a second, where you then actually start to see people walking in real time. So in this world, they've got switches, so you can do virtual patrols. You can do basically monitor specific information and stuff that you see. This is all done sort of real time. And so this technology is a mix between, it's basically like the metaverse. It's the mix between this digital twin world and a real world So companies like Foxconn have invested into this company, and you can see now this is an asset where you're mixing a traditional digital twin on the right with a real world digital twin on the left. So the applications for this technology go way, way beyond energy infrastructure, as mentioned. It goes into many others. This is Changi Airport. You can see there on the top there. With that digital twinning area, I'll start to move on to what the future can look like, and I think that's a good segue into what does that look like for what we're seeing. So I've been asked a few times around the future of energy transition, and we had a specific project that came up where a company, which I won't name, but they are a ride share company, had said, asked us around how do we transform the service stations of the future. So in the future world, we have all these service stations in developed countries that there won't be any petrol. But what does it look like if we think about transforming these service stations into a different concept? We're all familiar with applications now and apps, and these super apps enable us to do so many other things. In fact, they become a way of booking transport. What if with this information, we could basically then transform these service stations into logistics hotspots or cafeterias or places to meet? So rather than a place that smells of petroleum because it's all EV, we could start to build sector adjacencies into a petrol station, what would be a future petrol station. And not only that, it starts to impact planning of transport. So in the current world, we're in congested cities, we're struggling with how do we get to transport points, and typically there are train and bus stops. But now we're thinking, well, what if the service station could be a transportation hub where you could actually rent a vehicle or have it as a pickup point, and also use that as a place to interact. So if you think about that future, what we're looking to do is modeling the consumer to say, well, rather than just coming and paying out $50 for petrol, I'm now there to do a lot of other things. And technology as a super app enables you to seamlessly integrate that. And if you've seen many super apps around the region and around the world, that's kind of the way they play. So if you were to visualize that future model of a service station as a hub of activity, what could that look like? So obviously this has come from a AI generated image, but you can start to see how that spot could be slightly different to your traditional service station where you're actually going there to charge, but you could be renting, you could be doing your logistics pickups, your groceries. The opportunities are quite different, and the space is already there being underutilized for people coming in and pumping petrol. So this is just us sharing a little bit more about the future. And if you start to think about, well, what those ideas could be for you, that may not be the same, but my point of message here was really more around technology applications and using information to basically re-look at the way you would interact with your infrastructure points, using data and information like a super app, which anyone can build, to interact with your consumer base, and really look at thinking how using energy and data you could leapfrog and build different sectors together to solve different problems in your market. And this could maybe inspire you to think a little bit more about that. So with that, thank you for your time again, and really appreciate you listening. Hopefully you got to learn a little bit more, and hopefully there were some insights that perhaps you could take back to your countries and give you some ideas to sort of innovate around data and AI in energy. I'll stop there and I'll hand it back to you, Mike. Thank you.
Yeah, thank you so much, Darren. Very, very interesting, very futuristic outlook on many things. And the use of data science and AI has obviously accelerated a lot of things. And really hoping that energy transition and mitigation for climate change would also be accelerated. So we have a few questions. I'm going to start with a question for Luis. Luis, just confirm if you can hear us, but you join us over in the panel. But it's a question about can you tell us how your team started or convinced the utility business of Aboitiz to look into data science and AI? What kind of ROI and savings and impact resonated metrics, what kind of impact metrics ROI metrics, savings metrics resonated with your internal stakeholders? I guess has to do with convincing them. So can you tell us a little bit about that journey?
It's a difficult one, and for sure, because the culture of a power company is to take little risks. So when it came back to return on investment, they did not see AI as an exploration at first. They saw it as an investment, and they want a date and a time and IRR and PV for the return on investment. That being said, what we found is going after the core processes of the generation or distribution business that have the biggest capital intensity tend to be the best place to start. In our case, we started with boilers. We created a simulation, like Darren showed you, a simulation of 3D. We created a 3D based simulation with FEA and CFD simulations for boilers. We were able to promise and deliver, as of this month, 80% reliability on the model, on the simulation itself, which should lead to about a 95, 93% availability in the plant. That in itself unlocked all conversations because the net value of that is huge. We're producing 10% more power than we expected out of that if things go well. And then everybody was interested in other things, perhaps some that are not as I would say as powerful, but easier to digest. So there's two lines of thought. You could start with a simple Gen AI approach, ChatGPT, show that we can reduce the lead time to build documents or to capture maintenance documents and increase productivity by reducing FTEs, or just allow people to do more work. That's a way to start and show the power of it, but it's not transformational. Anything that you do on the side, Gen AI for document, for instance, will not transform the business. They will educate themselves, but what really helped us create a transformational mindset was, one, we ran about 30 hours worth of strategist courses to executives endorsed by the CEO for them to understand what AI is. And secondly, we created a program that goes at the heart of the business, where the money is made. If you don't have one, upskilling of understanding from leaders, and be a use case that hits at the heart of the problem or the heart of the business, it's going to be very hard to convince of transformation. Although you can have a edge use case to educate about what transformation could be. Hope that helps. But there's no easy answers. There's a lot of pain and a lot of work. Yeah.
Thanks, Luis. Yeah, I'd like to invite Darren to expound a little bit more. There was a question from the webinar Q&A. It's coming from the Pacific. We are sitting maybe short of data, which may be useful in AI, and resources are limited. How should we go about starting to integrate AI into our work? Is there another way around? Should we start from customer side and work to generation, et cetera, et cetera? Could you expound on this?
It's a great question, and I was trying to be really mindful around the differences between living in Singapore and what we're probably exposed to, and also Andrew Jeffrey's questions. I'll try and cover these off together. Rather than try and push ideas into your market, I think my approach would be first sit down with you and ask you and yourselves and your teams. If I look at my P&L for the year, like how I make money, right, top line and costs, and ask myself, and it goes to lowest hanging fruit around what are the inefficiencies or things that I could make a difference around, either getting more revenue, either pricing differently, and or costs around how does my company spend its money. So if I'm one bad year, could be a massive maintenance outage, or it could be the fact that I'm not buying my fuels effectively. Could be little problem statements like that. Listing those problem statements, 3 or 4 of them on the revenue side, 3 or 4 on the cost side, and then asking myself, what's the process by which I do that today? Is it manual? Maybe there's no systems. Maybe people are filling out forms as done. Could I digitize that? If I were to do that with data, does it effectively reduce or improve my situation? Or do I have systems where I could do that? Now, the AI pit comes in when you then ask yourself is, now, if I had more of that scale, if I could do that real time, or could do that, extrapolate with 20 years of information, or forward price that with 5 years of visibility, does that give me a better opportunity to, again, improve the way I operate? So I think most of the times I think really basic problem statements that you see, but applying a simplistic data mindset around, scaling that. And then AI really only comes in when you say, well, what if I had 100 people doing that? Wouldn't that be great? Well, then that's where AI solves that problem. So that's how I would start. And without trying to solve problems without knowing a circumstance, I think that would be, taking a client-centric approach to your situation. But I'm quite confident there are ways. The other thing, and just talking on behalf of now ADB, is having worked with ADB, is what if 10 markets had the same problem in the Pacific? Because of scale, you can't invest in that. Would there be an opportunity where ADB could then say invest it for one market, but apply it to 10 other markets where you all benefit from a similar problem statement, but because of capital investment, you don't have the capital to do that? Could that be an opportunity to work with ADB more effectively to do that? So, there are a lot of different ways to solve that problem. And I think, unfortunately, without the information, it's hard for me to solve it. But I think they are just some ideas of how I would think about solving that, rather than just saying, here's the answer for you.
Yep. Okay. Thanks for that, Darren. I'd like to bring back, I think it's related also to that question, but now back to Luis. For the first question about small utility in the Pacific, what do you see as low-hanging fruits for developing country utilities to start integrating such smart technologies and AI? I guess, with your experience, Luis, in looking at the Philippines, but maybe something smaller like islands, well, how do you think would you start in terms of getting low-hanging fruit out there for smart technologies and AI?
Yeah, and to be fair, look, the Philippines, it has some lo-fi solutions as well. There's places where we weren't gathering data at all, and we had to figure out a way to get it. The first thing I would say is, for any nation, island nation, or anyone that hasn't even invested in digital infrastructure, is get educated on what data is and what making decisions with data looks like. And that's an example that you just need a spreadsheet for. And give me an example. We run an exercise called data needs analysis, decision needs analysis. What does that mean? I need to understand what data will support my top 5 decisions in the company. And you can do that in operations very easily because your KPIs are probably tied to it. Once you understand that this decision can be supported by these data elements, then you know where you can invest data. And it's actually a lot easier to make a business case, because it's not about obtaining monstrous amounts of data that matters. It's about obtaining the right data. And right data is something that most companies and most countries are actually still struggling with. Singapore gathers a lot of information that is useless. We have a lot of dark data that we never use. And I'm a resident of Singapore, so I can tell you that I've been at this for 11 years. And most companies are data-rich, information poor. So if you're a company that is starting in underprivileged circumstances, I would say, by doing a decision needs, what is it, the true data that I actually need, you may be able to start leaner, and you may be able to make a use case. Go after what makes a lot of sense for you. For example, if you're struggling with reliability, the data that gives you a sense of asset life cycle and risk is the data that's going to make your assets more reliable and would make it easier for you to make decisions. And that may not necessarily be more than 20 data points, right? So again, if you get educated on what data is and how you make decisions with it, you'll be a lot easier to start with less money. One of the problems is we start with a lot of money and figure it out after if what we invested on has value.
Okay. So what I hear is that, you need to know the right data to be able to make the right decisions. And that's just maybe the starting point of a process. And before going into okay, I'm going to pass the same question to Darren. You wanted to answer that, well, maybe weigh in a bit.
Yeah, I think I would break it down into a similar thinking, which is what information could I, if I had more of, could I do things with? So, for example, and not knowing your markets well, but if I know the daily load shape on an hourly basis of my power usage by country or by city or by wherever it is as a building block, does that give me an opportunity to manage my supply demand of power generation? does that give me an opportunity to set tariff pricing to maximize? So for example, like if you've ever been an Uber or Grab or GoTo, you've got this surge pricing concepts where there's more demand, you're paying more. And in a way, the net impact of that is you actually get more revenue, even though some people are paying more. So the supply demand curve and pricing is something of information you can actually improve your revenue lines. The other point is cross-sector information. And again, I'm mentioning this more as a trend that we've seen across utility companies. Some of them, because of digital, are now moving into home utilities. So, everyone receives a phone bill, everyone receives a power bill, but why they're two separate companies running the same thing? And so the ability to look at the home bill to say, well, if I can distribute and deliver different similar adjacent products, could that be an opportunity to then monetize that household more in terms of revenue? So that's more of a strategic decision around partnering up with telcos, or in some worlds they have this MVNO where you're mobile virtual telco operators, but they're effectively utilities using data information, and you're bundling 1 + 1 = 3. So you're effectively now providing a more enhanced complete service to the home. So those two things I would look at. One is data at a very granular level. I think the question came around sort of crossing over and doing other areas. I would probably look at adjacent utilities that perhaps you could look at monetizing. And it's less about AI at this point. It's more around a digital platform or a digital engagement for the household, consumer, business, enterprise that you're looking at. And the problem statement is, what could I be doing more with a different type of way of engaging with with that user?
Yeah, thanks so much, Darren. So there's a question here that maybe slides into about standardized softwares or AI models. Can we just go buy from the market? Are these mostly tailor-made or customized AI models for the energy sector? Decision making should also consider the implementation aspects and operationalization. So, Luis, would you like to comment on that? In your experience?
Yeah, I can tell you that there are things that already off the shelf that are really simple for really small problems. So pump derision and loss of pressure is something that is really simple to predict if you understand a pump. And to be fair, the function of a pump is the same everywhere. You can buy algorithms from Aviva, you can buy them from GE, you can buy them from Siemens, and they all work relatively well, right? Now, is your plant or your grid, right, in a substation, for example, depending on these small little places where the algorithms are already relatively commoditized? Probably not, right? So the parts that are more difficult to standardize are the ones that are highly contextual to you. So if you are, let's say, an island nation and you run biomass together with some coal and you cycle through that in fuel, and it's completely out of the specs of the original equipment manufacturer, the reality is that no standard software is going to help you. You're going to have to contextualize it based on the fact that you run your plant that way. The same with the grid. I think that the problem with grid operations is that the way that our grid is built follows geography, not mathematics. So it's not ideal. It's got a lot of bottlenecks. It's got real challenges. And you need network scientists to understand your grid to be able to tell you where things may break. No software is going to do that for you. You need actual know-how of your own context. So if you were at a place where you want to accelerate, my advice to you strongly is to spend half of your money in acceleration in education. Get someone with understanding of physics, someone with understanding of mathematics into your organization to understand the problem first and understand the data value that you have and that you need, so decision needs, first. Once you have that in place, or while you're developing that, what you buy after will cease to be as risky. The biggest risk that I see with smaller companies is they go on a shopping list of whatever's already advertised as good, GE, Siemens, ABB, whatever, without no real understanding what they're buying. And they get themselves into trouble, because the reality is that no one's going to tell you shouldn't buy this. They're just going to tell you where they think the best possible chance there is for their product to give you some value. In reality is you shouldn't be asking some of these companies what I should buy. You should be picking based on what you already resolved the problem to be. So invest a little bit more in education. Get a whole new generation in your company, 5 to 10 people is enough, that understand data well and that can teach you about how to think of data as a problem. This would save you a significant amount of money when you go shopping for something off the shelf.
Yeah, so that's thank you, Luis. So it's important to know sort of a needs assessment, problem assessment, so to speak.
Yeah.
So I like that sort of
And do think that these people that you bring and educate will be curious enough to try things on their own, and knowledge is commoditized in the world. If you want to learn data science, you just need an internet connection. They may be able to create a proof of concept for you that you just then use to go buy something that already works. So in my view, that pays back easier.
Yeah, sounds good. So there's a question here that popped out, but I think I've just copied pasted it, but it was someone asking, and which is applicable, I think, to a lot of our utility participants here, and also for other sectors as well. How will AI affect the future workforce in the energy sector? As AI technologies automate more aspects of energy production, distribution, and consumption, what skills will be required and what roles will emerge or disappear in the energy sector? And how can companies mitigate potential job displacement? Darren, you want to take a stab at this first, and then
I'll go real quick, and then Lewis can add on. So I think in short, it will improve efficiency and replace parts of roles. I feel that the upskilling required is to Lewis's point around education and how to use technology to basically write those scripts. So if you think about data being ingredients to a meal, the chef is the one that decides what goes in the right mix. And I think we need more chefs in the way we think about using information and data. And through that, creativity comes out, and through that, way more, menus and dishes come out. So I think if you think of it from that point of view, that you need those more chefs to be able to basically transition away versus I'm making the same thing over and over again.
I like to think that our sector is an incredibly complex one. And today we run it very poorly. I've been in this business for 25 years, and I can't stand having that machine guru that touches the machine, closes his eyes, says, my knee hurts, maybe this will fail in 3 days. That's nonsense. We can't keep running power plants that way or power systems that way. We need to understanding of physics. The whole discipline of engineering needs to transform. So I think it's an emancipation of our solutions. The fact that you're no longer have to just have experience to run this. You can actually have data and evidence to run this. So there is a list of 1,000 jobs that we haven't yet created that are going to be necessary to run these very complex systems. All the people that can optimize an asset interaction, optimize a customer behavior, they don't exist. And they don't exist because we don't have the data for it. But once we do, we could be optimizing this. And these are jobs that don't exist today. The ones that should stop existing are the ones that capture data manually for 3-4 days in a row after an asset inspection round, for example. That is mind-boggling. The fact that we have people sitting in an operating room inside a power plant running manually things, that should go away. So yes, jobs will go away, and yes, more jobs will come. I think the trick is leaders like us that help design and take people along to learn their new function under a data reality. So think of as we become data centric and we become more aware, we cease to rely on experience and we become more and more understanding of evidence. So that in my view is where the jobs should go. I don't see a net loss of jobs. I see an improvement of jobs.
Okay, thank you so much, Luis. Maybe this has been a great session. Thank you, Luis and Darren. I'd like to hand off to Cindy, if possible. We can have a few words to close the webinar. You're on mute there, Cindy. Yeah, just.
So thank you, Mike, and thank you, Darren and Luis. Very insightful presentations. Certainly a lot of food for thought, as one of our participants said, Manny Adobai. And thank you for everyone who's been very engaged. Thank you for the very interesting questions as well. And certainly a lot that we can, possibly apply in our projects in the ADB. And thank you also for the advice and the recommendations. Thank you to our advisor, Andy Jeffries, for joining the call. And you know, it's great to see that ADB is interested in applying AI in everything that we do. So thank you to all, and looking forward to seeing you again in our next event in January. All the best. Give a round of applause to our speakers.
Round of
Please.
applause. Thank you very much also to our participants. For more information, you can visit the Emerging Areas Knowledge Sharing Series. I think it would have been in the meeting invite. We'll send you also some information. Yeah. Thank you so much. And thank you again, Luis, Darren, and Cindy, as well as the ADB.
Bye, everyone. Have a great week.
Thank you for the invitation.
Bye.
Bye.